different stream. So these sessions are going to help you with all these decisions. Today we have Mermil George with us, and he's gonna talk about machine learning in practice. So Mermil is a data scientist at Cisco. So I would request everyone to hear him carefully. If you have any doubts in between, which is related to the topic, please put it in the chat box. Do not disturb in between. Else, you can also raise your hand. He'll take up your questions at the end or in between if possible. Also, if there is any feedback or anything related to the session, put it in the chat box. I'll be sharing the feedback form also. Along with this, I'll be sharing the website, Apna website. So you can, visit that particular website and hear the recordings of the previous sessions, and you can also hear the recording of today's session. So and you can also register for the events. For in future we'll be having different various events, so you can also register for those events. So without much delay, I'm handing it over to Mermil George. Yes, Mermil, you can take it from here.
Yeah, thank you, Sneha. Yeah, I see one chat in the chat box asking to speak in Hindi. I don't know if I am going to disappoint you, but the medium of communication would be in English. So this entire webinar would be in the language English, and so kindly bear with that. I'll just shut down the camera so that I have more bandwidth put into the meeting, and let me share my screen. Give me a moment. Please let me know when you can see the screen. I hope it's visible. So, good afternoon, everyone. Welcome to Machine Learning in Practice, Real World Application. And let me give a brief introduction about me. I am a data scientist with 11 years of experience in data warehouse. Sorry. I would also request all the participants to go on mute. We'll take your questions once when session is done. So if by mistake, if you are in have unmuted, I'll request you to please go on mute, everyone, so that it doesn't disturb others. Please go on mute. Thank you. So I'll just give a brief introduction about me. I'm a data scientist who's working with machine learning and moving into the AI domain with almost 11 plus years of experience, starting from data warehouse, big data analytics, then coming to data science and machine learning, and now moving into artificial intelligence. I started my career as a data warehouse developer with Nielsen, and then moved to IBM as a big data cognitive specialist. And then now I'm in Cisco as a senior data scientist in ML and AI. I completed my BTech in computer science engineering from NIT Calicut, my master's in data science from University of Arizona, and my master's in machine learning and AI from LJMU. So that's a brief about me. And let's see what is the agenda for today's webinar. So first, I'll give you an introduction about what machine learning is so that you understand what is it. And then we go into much more deeper topics like what are the different types of machine learning, where is the application of machine learning, where does ML sit in the entire ecosystem, what is the process that we follow in machine learning, and what are the coding languages that is popularly used in machine learning. Okay, so whenever you have gone to Amazon website, you might have seen such kind of suggestions, right? Customers who bought this particular product has also bought this product. Customers have also bought this product along with this product. So you might have seen all those suggestions and recommendations coming from in Amazon, right? It could be based on multiple transactions that you have done in your historical transactions that you have done, or based on the transactions that are done by people who are similar to you. Now, if you go to any of the websites like Flipkart or Amazon, you should see such kind of recommendations, which is people who have bought this product A has also bought product B. People who has looked into product A has also looked into product B, kind of thing. Or else, most of you might be using Amazon Prime, Netflix, etc. Right? You might have seen such kind of suggestions there. Since you watched this movie, you might like this movie. Because you like this movie, these movies might be good for you, etc. All these suggestions come to you in Netflix. How do they work? What is the logic behind it, those things being suggested to you? That is where the idea of machine learning comes into picture. Now let's try to understand what machine learning is. Machine learning is an application or a type or a subset of artificial intelligence. There is a general notion across that machine learning and artificial intelligence are the same. No, they are not the same. Machine learning is actually a part of artificial intelligence. Now, the next question would be, what is artificial intelligence then? Artificial intelligence is when computers act on their own. They act according to the environment. Systems display cognitive ability and computers makes decision. Now, what does that mean? We humans, when we are put into a situation based on our previous experience, we try to solve the problem, right? Whenever you are put into, whenever you write an examination, based on what you have learned, what is the normal format of the answering, the technique in which you have to answer, you base on the previous learnings and then act accordingly. It's the same thing as that is what is artificial intelligence is. Instead of humans, when machines try to mimic human behavior such that when it comes across a particular situation, based on its previous knowledge, based on its learning, it tries to solve that problem, it tries to make decisions on the go. That is what is called as artificial intelligence. Now, to achieve this artificial intelligence, one of the major application that has to run is machine learning, because you have to learn what has happened in the history, and that is how you will react when a situation comes into picture. So artificial intelligence and machine learning are not the same. Machine learning is a part of AI. It involves, what does machine learning contain? Machine learning involves building systems or algorithms that can automatically learn from data. You have a lot of historical data with you. The machine learning algorithm or the machine learning system automatically tries to learn from it, whether there is a pattern to it, whether there is a anomaly case, etc. It tries to learn, and that is what is called as machine learning. Based on that historic pattern, what will machine learning do? It will predict what is going to happen, it will forecast what is going to happen. Okay. So an ordinary system, when it is enabled with AI, which contains ML, what does ML do? It learns, it predicts, and it improves. So an ordinary system, if it's enabled with AI, machine learning is a part of this AI. And what does machine learning do? It involves a system or algorithm that can automatically learn from the data, predict what is going to happen, and based on that prediction you can make improvements. And this machine learning is one of the application or one type of artificial intelligence. Okay, moving on. There are many different types of machine learning. Let's try to understand what are the different types of machine learning. First one is called as supervised learning. Now, as the name suggests, supervised means the algorithm, there is a supervision happening. You might have seen when you went to, when you go for an examination, there will be a teacher who will be walking around, right? What is that teacher doing? She's trying to supervise you. She's trying to look whether you are following the correct pattern, whether you are copying or not, whether you are following the guidelines of the examinations, etc. That is what is called as supervision, right? Now, there is a type of machine learning which is called as supervised learning. What happens in supervised learning? You try to bring an algorithm, or you try to develop a system, you train that system using labeled data set. Now the next question is, what do you mean by labeled data set? From the historical data, you try to take the input and the output, you give it to the algorithm and ask the algorithm to learn it, understand what is a mapping. So for example, historically, when someone is trying to do, I'm sorry, historically, when someone is trying to do a fraud transaction, the bank figured out this is a fraud transaction due to certain criteria, and that transaction is flagged as fraud transaction, right? So what does the algorithm do is it will take all those conditions which help the bank to decide whether it was a fraud transaction, understands it, and then tags it as a fraud transaction. So historically, whatever that was happened and what was the output of it is given to the data, is given to the algorithm. The algorithm learns that pattern, and then in future, when something similar comes, it will try to predict it, is what is called as supervised learning. Why is it called supervised learning? Because historically what had happened, you are giving both the input and the output, okay, so that in future when a similar set of input comes, the algorithm can go back and figure out that, okay, when this pattern of input is coming, the output was such a way, and so if this input is coming in future, then the output should be whatever that happened earlier. So historically what had happened is fed to the algorithm, and algorithm learns that and then tries to do a future prediction. The different types of machine learning under supervised learning is classification and regression. Classification algorithm is very simple. You might have seen in wherever you read about machine learning, you might have seen that a system trying to identify whether a picture is that of a cat or dog. It's trying to classify an input into output. Whenever you are trying to classify the output, it's called classification. Regression is, you know, what are your sales for the, there are different locations of your company and there are different sales that are happening, and based on that, in the coming year what would be my sales, you can predict it using machine learning. Whenever you are trying to predict a number, it is called regression. Whenever you are trying to predict a class, it's called a classification problem. This is what is supervised learning. Now why is it called supervised learning? It is called supervised learning because historically what had happened is being fed to the machine learning algorithm, where you have already told that these were the input and the corresponding output that happened is this. Learn that and tell me in future what is going to happen. Now the next one is called as the unsupervised learning, exact opposite to supervised learning. Here you do not give any learning to the algorithm. You give a dump of data and ask the algorithm to find the pattern by itself. You are not telling that when this input was there, this was the output. You are not telling that to the machine learning algorithm. You are telling that I have so and so data, give me whatever patterns or classification, whatever things that you can figure out, whatever insights that you can figure out from this data, give it to me. Simple example is clustering. Let's say that there is a class of 100 students, okay, and now you have the data of their height, their age, etc. Now you feed that to a unsupervised learning. What does it do is it can cluster them, it can form groups on different basis, right, of all the people of same height, or in a given range of height it can cluster, or people of the same age group, or people of the same marks, etc. So it gives you different ways in which you can cluster them, right? You are not telling it anything. The machine learning algorithm tries to find out a pattern by itself and says that, okay, these students can be clubbed together because they are of the same age group, these students can be clubbed together because they have the same height, etc. There is no supervision. In earlier scenario, what in your supervised learning, what was happening is you were telling that when this is my input, this was the output that I got, and so learn that how did it arrive at this output, and then in future when I give you the input, give me the output. That is what supervised learning is. In unsupervised learning, you just dump the data and the algorithm tries to find out. Another case is anomaly detection. For example, let's say that 100 of you are sitting in a room, okay, and you start asking each one their salary. Okay, people started telling my salary is 40,000, my salary is 20,000, my salary is 25,000. And let's say that one person was Elon Musk and his salary is way high. Now you didn't know that it was Elon Musk, and so when you take the average of the salary of the 100 people, your average looks too high, right? Because Elon Musk is having high salary. Let's take the example as Elon Musk is having high salary, and so when you take the average salary of the room would look way high. But was it really that? No. 99 people had an average salary somewhere between 30,000. It was just because of one person that the average salary went high. Now to figure out that, it's called as an anomaly. Such kind of anomaly can be detected in this kind of learning, unsupervised learning. Okay, so supervised learning, you give input and output, ask it to learn. In unsupervised learning, you dump the data and the machine learning algorithm tries to find the different patterns out of it. The third one is called as a reinforcement learning. Reinforcement learning. As the word suggests, you are trying to make sure that the result that is coming from the system is correct by giving feedback to it. So algorithm learns to make decision based on feedback that you give. Algorithm is given in this particular type of learning. What is that is happening is, you tell the algorithm that there is a goal, and the algorithm tries to take actions, learn from it such that it achieves that goal. Okay, for example, you might have seen this self-driving cars, right? So whenever a self-driving car goes through the road, it always try to avoid accidents, it always take the right directions, it always makes the right choice of uh, turning the steering, etc. How does that work? It is based on a feedback system that has been running in that algorithm for a long time. When it was going through the initial state, when it was supposed to take a left, the system didn't know it had to take left. So we trained it telling that you have to take left, and the next time when it was supposed to take left, if it took left, then you give the feedback that that is the right one. If it had taken right, you would tell that the feedback it is the wrong direction, and then it tries to learn from all these feedbacks, and then eventually it will become a robust system. So supervised, you give input and output. Unsupervised, you dump the data. Reinforcement, you give feedback of the decision that the system made. The last one is a semi-supervised learning, which is a combination of both supervised and unsupervised. A set of data you do unsupervised, and a set of data you do supervised. That's a combination, and this is called as semi-supervised. It's a hybrid of supervised learning and unsupervised learning. So machine learning, when a system tries to learn, predict, and improve, that is called machine learning. Types of machine learning: supervised machine learning, unsupervised learning, reinforcement, and semi-supervised. Moving to the next one, let's try to understand a few examples of machine learning. Okay, supervised learning: price prediction, churn prediction, etc. For example, imagine that there is a particular area and there are a lot of flats there. Okay. And when you look to the previous 2 years, you have seen that a 2 BHK flat, which has a garden, the price was this much. Another 3 BHK flat, which the selling price was this much. It was sold for this price. 5 BHK, the price is less. So you have the data for previous 2 years of flats that were sold in a particular area. Now there is another flat that is there up for selling, that is up for selling, and you want to predict what could be the probable price that if I put on this flat, will the people be attracted? In such scenario, you use supervised learning, because for the past many years, what were the different dimensions of the flat, what were the facilities that were available, and what was the price at which it was sold, so you give all that data and ask the machine learning algorithm to understand what is the relation between whether two bedrooms are giving me more price, three bedrooms are giving me more price, whether if there is a metro station nearby, whether it will increase the price or not, etc. You're trying to, you give all this information, and then the machine learning algorithm tries to find the relation. And then next time when you tell that, "Hey, I have a 2 bhk which has a garden, there is no metro nearby," if that is the scenario, what is the best price at which I can sell based on what you have learned? That is what is called as price prediction. Then comes churn prediction. Churn means uh, whether a customer, so for example, you all might be using your mobile phone, right? Few of them might be using Airtel, few of them might be using Geo, etc. If a customer moves from Airtel to Geo, then that customer is considered as a churn customer for Airtel, because he was in Airtel and then he moved out. Such customers are called as churn customer. Now, it's a classification problem. The first one, price prediction, is a regression problem, whereas this one is a classification program where you are trying to predict whether a customer will stay with us or will move out of it. Okay, so that's the old. And again, the logic behind it's the same. For example, you look into a customer and then you see that this customer has not been using his data pack for the past 6 months. He has not been making calls, and then he churned out. Yes, churning, yes, one. And then for another customer who has been using a lot of calls, he's still with us. So what is happening is you give that historic data and tell that there is this customer moved out, this customer didn't move out, the next customer didn't move out, the next customer moved out, etc. So you're giving that historic data to machine learning algorithm, and the algorithm tries to learn what is the relation, and based on that relation, it will look in future, it will say that, okay, this customer, the way he is not using the phone, I think he is going to churn out. It will predict that, and then based on that prediction, Airtel can send out promotional offers telling that, hey, why don't you stay with us? We'll give you a package which is of 200 rupees right now at 100 rupees, so that the customer remains with Airtel itself. So that's the supervised learning. For unsupervised learning, I already told the example of clustering and anomaly detection, where you have 100 people, you look into the salaries, and there is one person whose salary is way high, he's called as an anomaly. You have 100 people, you try to group them into different buckets based on maybe height, age, or salary, that's called as clustering. Here, you are not telling the algorithm what is the input and what is the output. You are just giving the data, you're just giving the input and asking it to figure out the output by itself. That is what is called as supervised learning. The third one is the autonomous driving, etc., which comes under reinforcement learning, which, as I explained, is based on a feedback system. It tries to understand how it should make a decision at a particular situation based on the feedback that you gave to the system about the decision that it made. Say, for example, when an autonomous vehicle took a left turn, you give the feedback that left turn was wrong, right was supposed to be taken. So the system takes a decision, and then it gives that decision for which we humans give the feedback, and based on that feedback the system learns, and the next time when it is supposed to take a left, it will take left. So that is where the reinforcement learning kicks in. The last one is the semi-supervised learning, which is classification and labeling. Here you classify different objects on the basis of a previous historic supervised learning, or it can do labeling. Again, very simple to understand. Semi-supervised learning is a mix of supervised learning and unsupervised learning. Now, moving on, where can you see the application of machine learning in your real life? Okay, the best example is if you go to Gmail, you might see all those mails in a particular folder called as a spam folder, right? How does Gmail figure out that these mails are spam mails? Historically, whenever there was a promotion mail or whenever there was a fraud mail, Gmail tagged it as spam, and then there is an algorithm running behind which tries to check if this pattern is there in the new mail. If that pattern is present, it tags it as spam mail. Okay. NLP, natural language processing. Nowadays, whichever site you go, there will be a chat bot on your very left hand bottom where you can click, ask your questions, etc. Behind the scene, it's a machine learning algorithm that runs, and it's based on the principle of natural language processing. It tries to understand what the question is, and based on its training information, the knowledge that it has previously learned from the data that we fed into, it will try to answer the question. Next one is the image recognition. You might have seen certain alarm system, right? Whenever a person comes and tries to open the door, the alarm rings. So it's based on something called as the image recognition. There are scenarios where you might have seen Tesla car or all those electric cars which has autonomous driving trying to brake itself by itself when it sees an object in front of it. How does it figure out? It tries to do an image recognition. How does image recognition work? There is an algorithm which was told that if there is things like this of this dimension, it's an object in front of you. If you see an object, you should stop it. Okay, all those things. This is a combination of reinforcement learning plus supervised learning that is happening in image recognition, which works in self-driving cars. The last one is the recommender system, which is the most common thing that everyone might have come across. You getting recommendation in your Spotify, in your Netflix, in your Amazon, everywhere you will see recommendation. If you have liked this song, you will like this song also. The next song in YouTube, you automatically start getting videos, right? It's based on what you saw. They try to predict, they try to do a prediction of what you might like, and they push it to you. It is called as the recommender system. Now, where is ML sitting in the entire ecosystem? As I explained at the beginning, artificial intelligence is where you have a computer system or a machine trying to mimic the behavior of humans. Machine learning is one of the important part of this artificial intelligence, important part or important type. Now, you might have come across certain terms like deep learning, etc. Right? Please do understand that machine learning, deep learning are different things, but machine learning, one type of machine learning is deep learning. Okay, it is based on a concept called as neural networks, which is a bit technical. For the time being, I'm not explaining that, but I've heard many people asking me this question: what is the difference between machine learning and deep learning? That's why I've put this. Machine learning is where you ask the system to learn based on the historical data, do prediction and improve it. One way of doing that machine learning is called as deep learning, where the algorithm is based on neural networks, just like our brain works. When you feel a touch in your hand, the nerve system sends the signal to the brain and makes you understand that you felt a touch. When you get a smell, your nose has the nerves, that nerves send signals to your brain, and you figure out what that smell is, right? So such kind of neural networks is used. We are trying to mimic that neural networking system to do prediction. That is what is called as deep learning. Now, where does data science sit? Data science is when you know mathematics, statistics, you know to do exploratory data analysis, when you know to do visualization, and you know the concept of artificial intelligence, which contains machine learning, which contains deep learning. When you have both these skill set, that is where data science sits, and that is people who know both these set of skills, they are called as data scientists. Okay, so for a data scientist, you should have idea about artificial intelligence. You should know a lot of machine learning. You should know deep learning, etc. You should be good with math. You should be good with statistics. You should know how to build charts, bars, etc. You should know how to do analysis. You should know what are the technologies out there, etc. And then you become a good data scientist. Now, what is the process that we follow when we do a machine learning project? The very first thing that you do is identify the data. You need to figure out what your data is. If it requires any kind of pre-processing, you have to do that pre-processing. Now, what is this pre-processing? Let's say that your data has bad records or missing records. For example, there is a column with phone number, right? And in that phone number column, you see ABCD. That is wrong information. That is bad information. You need to do pre-processing to remove such bad information. So that step is what is identifying the data and the pre-processing. The second step is called as the algorithm choosing, which is nothing but based on what you are trying to achieve, you choose the algorithm. For example, your use case is to figure out whether the picture contains a man or not. It's as simple as a classification problem, right? It's a yes or no question. You are given a picture and you are being asked whether there is a man or not. So yes, there is a man. No, there is no man. So it's a yes or no question. So such questions are classification questions. So classification algorithms are a set of algorithms. Now, let's say that you have the data where you are supposed to predict what will be my company's sales for the next year. You are trying to predict the sales. It's a continuous number. So it will be a linear regression problem. So it's based on the data and the use case in hand that you choose the algorithm. Next one is, after you have chosen the algorithm, you have to code it, you have to model the algorithm. You'll have to write the code, you will have to train the data, and then you build that model. Okay. After the model, you figure out the coding and modeling, you start training it, you test it, you validate it. You train the data telling that historically this was my input and output, try to learn from it. Okay, let me test, if this is the input, what is your output? You try to validate it. You are trying to check whether, okay, in my testing, when I gave this, the model predicted that this is what is going to happen. Was it the real correct answer? You check that and then you validate it. So you build a model, you train it by historic data, you test it whether it's giving a prediction, and whether the prediction is right or not, you validate it. And the last one is, you, once when you are satisfied with the accuracy of the model, once when you are satisfied that my model is doing a good job, then you will push it to the production, and then tries, you monitor that algorithm every now in a periodic way. You check whether the algorithm's predictions were right or not periodically, and if there are errors creeping in, you go back and then again do this retraining. So the machine learning process very simple. You identify the data first. Based on the data and the use case, the problem in hand, you choose the algorithm, then you build the analytical model, you train the model, and then you productionize it. There are basically and most popularly used ML coding languages. First one is the Python and the second one is R. Okay. Python is a general purpose language. It has a very simple syntax. It has a lot of libraries and frameworks. It has excellent compatibility with big data, and there is a strong community who contributes to documentation, etc. And Python is one of the most familiar and most widely used coding language. Whereas R is more towards statistics. It is more towards mathematical model building. It has a lot of visualization features. It can handle large data in RAM, etc. But R is very good with numbers. And hence, when you look into natural language processing or deep learning, where a lot of words are involved, R is not a good choice. Python is a good choice. R deals with numbers, and hence it's not an ideal choice for NLP, deep learning, etc., where you are working with mostly words. Natural language processing is where a text bot or chat bot is there. You type in words and then that words is being trained on, right? R is good for mathematical things, whereas Python is good for everything. And that is why Python is more famous than R. Majorly, these are the two coding languages that exist in the industry right now. There are many other coding languages, but majorly, most of the applications are built on Python and R. And both these languages are open source. Open source means the development code, everything is available for in the system, available in open, and hence anyone can download it and contribute to it and use it. Hence, it's widely used. You do not have to pay proprietary fees for it. In Python, let's go. I'm giving you a bit more details about Python here because it's one of the it's one of the famous language. There are a lot of libraries. Now, what does this library mean? Libraries are those keywords that you can use in coding, and without having to write the functionality, you can call it. So, for example, let me explain it with in simple words. You have to add two numbers, a plus b. So you can write the code for that, telling that a plus b is equal to c, and when I call sum, give me, if I call sum of a comma b, you have to give me c, which is a plus b. You can write that code, or you can call a package which has this functionality already written by someone and is kept there as a package and use that. So in Python, most of the things that you want to do in your daily life regarding analysis, someone or the other has already developed a code for it. They have nicely packaged it and it's available. All you have to do is call it and use it. So such packages that are available in Python are NumPy, which is basically used for numerical functions. That is why it is called as NumPy, numerical Python. Scikit, where there is a lot of machine learning algorithms that are there. TensorFlow is basically a package that helps you to build deep learning models. SciPy is again another one which helps you to uh, create different visualizations, helps you to do data manipulation. Pandas is again another package that helps you to do high level abstractions and creating data structures, etc. So, oh, this is another one which is the matplotlib, which helps you to create charts. Keras is again used. This is Keras, which is used for building neural networks. Deep PyTorch is another one which will help you to build neural networks, etc. So, in nutshell, what you have to understand from this slide is there are a lot of packages, there are a lot of uh, pre-built codes that is there in Python which you can reuse so that it helps you from bypassing, or it helps you from coding a lot. You just need to call that package, use that package, rather than writing the entire code, entire machine learning algorithm. No, nothing. See, for example, linear regression machine learning algorithm. If you are really trying to code it, there is a lot of coding required. Whereas you can just simply call it from a scikit and then tell that use the package that is there in scikit for machine learning, for linear regression. Use this input and give me the output. Okay. So that's how the different libraries work. Now, it gives you a basic idea of where does your Python library sit. So Python is the high level language under which you have the different frameworks, which is TensorFlow, MXNet, etc. And in these frameworks, you have the different libraries. Pandas, which is for data wrangling, Matplotlib for data visualization, scikit-learn for building your traditional machine learning, Keras for deep learning models, etc. Now, a simple flowchart of how you can approach an ML task is, first thing is, when you get an ML task, check whether it requires neural networks or not. If it requires neural networks, then the obvious choice for library is Keras. If it doesn't require neural network, try to find out what is the type of problem in hand. Whether you are supposed to do any calculation, machine learning, model building, etc., then you go for scikit-learn. If only visualizations, etc., is required, you go for matplotlib. It's a very crude methodology to figure out which package should I be using. Now, last one, why we have this webinar, why are we talking about machine learning, what is the future of machine learning? There is intense use of machine learning in artificial intelligence that is going on here. You might have been hearing this word of generative AI everywhere, right? Gen AI, the base sits on machine learning. There is a lot of algorithms that run behind machine in your Gen AI, like your large language models. You might have heard about LLMs, right? Again, large language model. What is a model? Model is nothing that is based on machine learning. Machine learning. So everything that you see now, which is moving towards AI, is based on machine learning. Any technology that you take, IoT or cyber security or robotics or uh, augmented reality, blockchain, cloud computing, virtual reality, anything that you take, there is a high percentage of machine learning algorithm being used in it to survive and in it to flourish. Similarly, you take any industrial sector, right? Be it healthcare, be it finance, be it autonomous driving, transportation, be it e-retail, or be it supply chain. Everywhere there is machine learning algorithm that is implemented. What is the best route to supply my product, whether from Delhi to Bangalore Airways, from Bangalore to a particular location in Bangalore, the best way is via two-wheeler, etc. Supply chain management, the optimized ways in which you can do different things in healthcare, trying to figure out based on the scans and the reports whether there is trying to detect cancer, etc. In finance, we're trying to, in banking sector, we are trying to figure out whether a particular transaction that is happening right now is a fraud transaction or not. Cyber security, your e-retail where you get recommendations, suggestions, etc. These are just few to name. You take any industry out there, there is machine learning involved in it. And why machine learning? They want to do a certain level, they want to the system is trying to, the industry is trying to avoid mere manual labor by bringing in this machine learning algorithms. Earlier, how it used to work is someone would sit behind, try to figure out manually whether there is this happening or not. Now you are training a system, that system will do it for you so that humans can get involved in other more productive work. So what is the future of ML? You take any technology, you take any industry, there is high use of machine learning algorithm, and hence machine learning acts as an important part in your AI growth. Okay, so let me just summarize it from the beginning before we wrap up. First thing that we learned about was what is machine learning. Machine learning is a subset of artificial intelligence. You know what artificial intelligence is. Artificial intelligence is when a system tries to mimic the behavior of humans. Based on our learning, we make decisions when we are put into a situation. When a machine tries to do that, it's called as artificial intelligence. And one of the subset or one of the application of artificial intelligence is machine learning. Machine learning is when you try to teach an algorithm or a system, try to teach it with the historic data so that the system can predict the future and then improve it accordingly. There are different types of machine learning, which is supervised learning, where you give both input and output, ask the system to understand the relation and then predict the future. Unsupervised learning, where you just give the data, ask the system to figure out the patterns that exist in that data by itself. Third one is the reinforcement learning, where you give feedback to the decision made by the system, and then based on that feedback, the system tries to learn more. And the last one is semi supervised, which is a combination of both some supervised and unsupervised. Then you went on, so few examples of these supervised learning, unsupervised learning. For supervised learning, you understood what is classification problem, what is regression problem, price prediction, churn prediction, etc. Then when you learned about unsupervised learning, which is clustering, anomaly detection. Then you learned about reinforcement learning, which is the autonomous driving, gaming techniques, etc. And then from there, you try to understand the common things that you have been seeing in your life where machine learning is involved. Your spam mails, your spam messages, then that is one example. Then trying to check whether a transaction is fraud or not. Then you are trying to the next one, where you have your chat boards, then where you have your autonomous drivings, etc. So you saw different examples that are happening in your real life where machine learning is involved. And then we saw where does machine learning sit in the entire ecosystem, what is data science, who a data scientist is. When you know when you know the concepts of AI, when you know the concepts of machine learning, when you understand deep learning, etc., along with you have knowledge in statistics, exploratory data analysis, knowledge in technology, coding languages like Python, etc., you fall in the field of data science, and that is who a data scientist is. Then you went when we saw the different coding languages that are used, which is Python and R. What are the benefits of Python? What are the problems with R? We saw that. And then at last we saw what is the future, in which sector, every industry, every technology that is out there, there is heavy use of machine learning. And hence the more AI that comes into picture, more ML will be used. All right. Now let's go to the question. Any questions?
Yes, guys, if you have any questions, please go ahead and ask. You can unmute yourself and you can ask your queries. If not, you can put it in the chat box as well. We'll address it.
Uh, One of the question that I see in the chat is, can you provide hospital management related program? Gopinath, can you be a bit more specific? Is it a course that you're referring to that is being catered by Apna, or are you asking about an algorithm that can be used in hospital management? Yeah,
I guess he has left the
yes,
meeting.
yes.
No, no worries, no worries. Okay, if anyone else you have got any queries, please ask. If not, we'll conclude the session. Also, I have dropped in the feedback form. Please fill it. This will help us improving. If you have any topics that you want us to take up for the next session, please suggest. And if there is any improvement that we can do, we can consider that as well. So please fill the feedback form. Okay, so I don't see any questions coming up. So let's conclude the session for today. Thank you so much, Mermil, for joining us today and for sharing your expertise with us.
Thank
And
you.
I believe people have found this session useful, and we were able to, uh, address what they were looking for. Thank you everyone for joining in, though it is a weekend today, and still you people have given your time and joined in. So that is really grateful. Also, you can visit our website. The link is in the chat. Here you'll find the recording of this session, also the previous session, as I have informed earlier. You can check for the upcoming events and register there. And hope to see you in the next session. Thank you, guys. Thank you, everyone, for joining in.
Thank you so much. Have a great weekend, all.